Good morning, children. So we'll continue the same thing where we left there with reflection and refraction chapters. So till now we studied about the reflection of spherical mirrors, how they are, and the parts concave, convex, or whatever it is, and the image formed, and how the image formed, where it is formed. I told you to go and practice with ray diagrams. So it is given in your study materials also very neatly. So you practice them. So if you won't understand, tomorrow you will be coming to school, there it will be explained. But the main thing is you have to go through the things which you have told you already. If you go and do it, then only you will understand, or else you will not understand anything. Now we will continue with refraction. So what do you mean by refraction then? So you might have observed that the bottom of a tank or a pond containing water appears to be raised. Similarly, when a thick glass slab is placed over some printed matter, the letters appear raised when viewed through the glass slab. Why does it happen? You may see a pencil partially immersed in water glass tumbler. It appears to be displaced at the interference of air and water. You might have observed that a lemon kept in water at a glass tumbler appears to be bigger than its actual size when viewed from the sides. How can you account for such experiences? So what he's saying is, so when you are dip your finger into the glass of water, you may see that the finger has been raised. Or you put a lemon in water containing, you see that the lemon has been raised. Lemon ಸ್ವಲ್ಪ ಮೇಲೆ ಬಂದಂಗೆ ಕಾಣುತ್ತೆ. ಸೊ ಯಾಕೆ ಕಾಣುತ್ತೆ ಆ ಥರ? ಒಂಥರ ಪೆನ್ಸಿಲ್ನ ಡಿಪ್ ಮಾಡಿರಿ ನೀರಲ್ಲಿ. It contains water in a glass which made up glass. So from the side you can see that the pencil has bent. So you can see slightly the pencil has bended like this. So why it happens like this? What makes them to happen like this? So this is all because of refraction. Let us see what you mean by refraction here. These observations indicate light does not travel in the same direction in all media. Underline this one. Light does not travel in same direction in all media. This is a very important point. What he's saying is, light does not travel in the same direction in all media. Media means it may be water, it may be oil, it may be petrol, it may be diesel, it may be air, or it may be anything else in which the light is traveling. So it will not be in the same direction in all the medias when compared with all the medias. So how it happens then? Why it is happening like this then? Let us see. The direction of propagation of light in the second medium changes. This phenomenon is known as refraction of light. So I told you already. So what is reflection of light? Oblique from one medium to another medium. It appears when traveling obliquely. When light travels from one medium to another medium, whether it may be from air to water or water to air, then the direction of propagation of the light in the second medium changes. Means when the light is traveling from one medium to another medium, then the direction of propagation of light in the second medium. Keep it in mind, the direction of propagation of light in the second medium changes in second medium. So this is called refraction. So what is refraction? When the light traveling obliquely from one medium to another, the direction of propagation of light in second medium changes. This phenomena is known as refraction of light. Let us understand this phenomena further by doing a few activities. So he has given the activities there. Some activities can be done here, but not all the activities. The activities are possible activities where we can do, so we can go with that, or else we will see it. Reflection through a rectangular glass slab. So what he has given? To a rectangular glass slab. If you take the rectangular glass slab, so how the reflection of light will be there? So when it travels here, so lightly it bends here. So this is the normal ray. It has to be like this, but it will not travel like this, but it bends here. So if we take this as point as E, this is the F, and this is N, and this is, so this is also a distance is given there. So you can take M here, and P and everything here. See, that is the second law of reflection I told you there. So the incident ray, the refracted ray, and the ray of incident, they will all lie in the same plane. This is what it says. So what is that is in rectangular. How it will be there? In this activity, we will note that the light ray has changed direction at points O and O dash. So the light has changed its direction. So why the light has changed its direction in this process? It is because of refraction. So refraction in the sense I told you already, when the light travels from one medium to another medium, they will be in the second medium, the propagation of light changes in the second medium. That is called refraction indexes. So here one medium is the air medium and the second medium is the glass medium. So when the glass is traveling, when the light is traveling from air to the glass medium, the propagation of light goes on changing here. Now you are familiar with the refraction of light. Refraction is due to change in the speed of light as it enters one transparent medium to another one. This is also important one. You underline it when you go through the textbook. So what he's saying is, with the refraction of light, refraction is due to change in the speed of light. So why refraction is there? It is because change in the speed of light as it enters from one transparent medium to another transparent medium. So when there is a change of direction from the light is traveling from one transparent medium to another transparent medium. This is given here. And the following are the laws of refraction of light. He has given the laws of refraction. The incident ray, the refracted ray, and the normal to the indicate of the two transparent media at the point of incidence all lie in the same plane. I told you already in the beginning, the incident ray, the refracted ray, the point of reflection, and the normal all lie in the same plane. They will not be over the plane, they will lie in the same plane. And second says the ratio of sine of angle of incidence is the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This law is also known as Snell's law of refraction. Underline and give it down what is Snell's law. So in simple telling, Snell's law is nothing but sin I by sin R will be always constant. So the refractive index. What do you mean by refractive index? So refractive index, you have already studied the ray of light travels obliquely from one transparent medium into another, will change its direction in the second medium. The extent of the change in direction that takes place is given in a pair of media, may be expressed in terms of refractive index. So how it changes? So how much it changes? So what is the readings for different mediums? It will be given in the form of refractive index. So first one is N1 equals to V1 by V2, that I told you already, the change of direction of light from one medium to another medium. Then N12 equals to V1 V2 by V2. We have 10.6 there where the light changes from one medium to another medium. So Nm equals to C by V. This is important here. So we have C by V. So what is C by V? Is nothing but speed of light in air divided by speed of light in medium. So this equals to speed of light in air by speed of light in medium. So one is speed of light in air, another one is speed of light in medium. So this is how we will get the refractive index here. One from the speed of light, that is Nm equals to C by V, that is nothing but speed of light in air by speed of light in the medium. So how the light is traveling in air and the speed of light in the medium when the light changes its direction from one medium to another medium. The medium may be anything. The medium may be, I told you, the medium may be air, glass or whatever it is. When the light is coming from one medium to another medium, there will be slight reflection in the direction of the light, and that is counted in the refractive index of light. That is called reflection of medium. Okay, children. See, he has given different refractive indexes of different material. I told you already, the refractive index is nothing but measurement of change of the medium of the object, light when it transfers or when it goes from one medium to another medium. That measurement, when you calculate it, you will get the refractive index. So by seeing the refractive index, we can say that how much the object appearing upside or object is down there. So he has given many different types of refractive indexes here. In the table, if you observe it, it has given more there. So material medium he has given air, refractive index is 1.003. Material medium is Canada balsam, and refractive index is 1.53. This is very important. So you may ask us where we use these refractive indexes generally. Generally refractive indexes are used. You may see in different types of colors in ice creams, different of colors in juices. Down will be yellow. When you put some other colors of juice, then it will won't mix with that juice. You will get a blue color. So why it happens all this? Because of different refractive indexes. When it is there, then you can see this thing very clearly in there. So this is about refractive indexes. Then refraction by spherical lenses. Now till now we studied about the mirrors. Now we'll go for lenses. I told you already what do you mean by lenses. There are two types of lenses. One is concave and one is convex. Convex is diverging or converging lens. It is a converging lens, and concave is diverging lens also. So a transparent material bound by two surfaces of which one or both surfaces are spherical forms of lenses. This means the lens is bound by at least one spherical surface. In such lenses, the other surface would surface bulging towards. That is nothing but I told you already. Two surfaces are there. I showed in the last class also. That is, one is like this. It will have the point of curvature. If you take A and B here, so it is a convex lens. This is convex, and if you want concave, you will have like this. The point, you can write A and B here, and this will be there. So this is concave. So one we have convex lens, another we have concave lenses. But there are two types of lenses. So what are these properties of two types of lenses? How they behave when the light travels in these two types of lenses? One is convex, another one is concave. So what type of behavior the light does when the passes through these two types of lenses? Let us see. He has given there converging action of convex lens and diverging action of concave lens. I told you already, concave is a diverging lens, means it spreads the light. Convex is a converging lens where all the rays of light will meet at one point, so that it is called convex lens, and concave is diverging lens. If we remember these 2 points, is well and good. The first point is convex lens, where the lens, all the lights will converge. Converge means meet at one point, and concave means diverging lens, where the light will spread there. So he has given there, usually represented by the letter O. The paper begins to burn, producing smoke. I told you, if you want an example, you can take. You have the lens in your home. Kannadadalli booth kannada anta karitತೀವಿ ನಾವು. That is a enlarging lenses we use. If you take that lens and put it on paper, so all the light which is passing through the convex lens meet at one point on the paper, so that the light becomes very strong. Light becomes very strong in the sense the power becomes strong, and the light starts burning. All the light starts lighting the paper. Lighting the paper means it makes the paper to burn itself. So this is the properties of convex. But this you will not get in concave lenses. The best example is magnifying lens, where we use there. If you have magnifying lens in your home, so you can go with these type of things. If you have magnifying lens in your home, he has given everything nearly in it nearly. Image formation by lenses. How the image is formed by lenses he has given there. So what type of image is formed, whether the image is inverted or real, or whether it is diminished or very point sized, it depends upon where the image is falling there. For example, he has given the position of the image here. First, the position of the image is at infinity, where we cannot see the position of the object there, where the object is at infinity. Infinity in the sense, exactly we don't know where the object we are keeping there. So that type, the focus and the image formed is real and inverted. And we have behind to f1 focal length. I am telling f1 is nothing but the focal length, so it is also real and inverted. And the optical center, this is very important, it is virtual and erect. See, I gave the example of Hampi also. I think if you go to Hampi, inside the Hampi we have one room there where you can see the whole tower of the Hampi tower is inverted in that room. You can see the shadow of the inverted tower in that room when the light is passing through a small hole there. You can see the small hole there. So when the light is passing through the small hole, the total tower will be inverted there, and it will be real image, but it will be an inverted image. So I told you already the real and inverted image. So this is the biggest thing. Now we are studying all these things. At that time only they see the scientific emergement at that moment when they did these type of things. Where to place the image, where is the image, and where to place the lens, and where to place the wall, so that you will get a clear picture, that is inverted image of the tower, as well as it is clearly and virtual it is. So this is the best example where you can give here the formation of these type of images in convex lenses there. Okay. Now, image formation in lenses using. Okay, children, you can see the picture also. There we have the picture, the Hampi picture there, where you can see clearly the tower of the main tower of the Virupaksha temple. It is totally inverted in the one room, in the small room, and it is dark room where you can see the inverted image of that tower. See, very astonishingly, it is very, very interestingly to place the hole. Where to place the hole is very important in this concept. Why? Because here we are using the lens there. So where to place the lens? See, how do they came to know that the hole should be at that point only, so that we will get a clear inverted picture of the tower where it is totally real and inverted. This is very important point of this picture. Okay, children? I think you understood this concept here. Now, image formation in lenses by using ray diagrams. So how the image is formed in lenses by ray diagrams. Ray diagrams in the sense, when you pass the image in convex lens at the focal length or line of curvature, so where the image is formed, at what place the image is formed, he has given. So both you can see in figure 10.4, he has given two pictures there. One is convex lens and concave lens, where the image is formed in focal length f1, and in second figure, that is focal length f2. Formation of images will be totally vertical as well as clear. And the ray diagrams of the image formation in a convex lenses for a few positions of the object are shown. These are very important things here. Why? Because these you may get the question in the examples also. Internal erect, real erect images, how the images are formed, and what types the images are formed, how they are formed. This is also very important concept which has been given here. The formation of images in this picture is very important here. So, sign convention of spherical mirrors is given. Same thing I told you, 1 by V minus, this you take down, 1 by V minus 1 by U equals to 1 by F. This is one he has given. So in the last class also we studied there, but it is what not 1 by F there. Sorry, it is totally different there. So focal length of convex is positive. You remember this one, very important. Focal length of the convex lens will be always positive. Focal length of the concave will be always negative. See, focal length of the convex is positive and focal length of the concave is always negative. This you should keep it in mind. These are two important things. If you know these things, one is positive for convex and negative for concave when you compare the focal length. And magnification, same thing, magnification in spheres he has given there. So you have magnification in lens also. The same thing we have h1 by h dash. So magnification m is given by magnification M is given by H1 by H. We have already discussed this one, V by U. So this is a magnification of the lens. How much the image is magnified? Generally that we use in telescopes or simple microscope or compound microscope where the magnification of images are done here. So he has given again some problems related to this one. This I will explain you in the classes so that it will be easy for you. Then power of the lens. So what is the power of the lens? How you calculate the power of the lens he has given? The power of the lens is nothing but P equals to 1 by F. What is the power of the lens? The power of the lens is nothing but P equals to 1 by F. So when you say P equals to 1 by F, then it will be the power of the lenses. The SI unit of the power of lens is diopter. It is denoted by the letter D. If F is expressed in meters, then power is expressed in diopters. Thus, 1 diopter is the power of lens whose focal length is 1 meter. 1D equals to 1m. You may note that the power of the convex lens is positive, that of a concave lens is negative. This also I told you in the beginning only. The convex is the focal length is always positive and the concave is always negative. So the main thing what you have to observe here in this chapter is the ray diagrams of reflection of spheres as well as lenses, and the ray diagrams of convex lens spheres and as well as lenses, both concave and convex, and some simple formula is given there, and here you have law of reflections of 2 laws are there. So I think you know the 2 laws, and go with the laws also. And if you want a complete explanation, so this can be explained through this one. So this is what is about this chapter. So if you any have doubts regarding on this chapter, so you go through the thing which has been given, that is all the materials. So still if you want to understand, that will be explained in the class for this purpose. Okay children, and thank you, and we will continue in the next class. Thank you children.